Today we will discuss the competition between the substitution and elimination reaction. And the condition that favor the E2 reaction also favor the SN2 reaction. And all the conditions that satisfy the E1 also favor the SN1 reaction. But do not worry about the competition between SN2 and E1 because the conditions are entirely different, and similarly SN1 versus E2 combination. So first of all we have to decide whether the reaction would favor SN2 or E2 or SN1 or E1 reaction. So if the halide is primary, then SN2 or E2 need to be considered, because we have in both the SN2 and E2 reactions a transition state is generated. So in order to avoid the maximum steric hindrance, in the case of primary alkyl halide, SN2 or E2 reaction is preferred. And whereas if the halide is secondary or tertiary, SN2 or E2 or SN1 or E1 can be take place depending upon the reaction condition. Now consider this example. Our starting material is a primary alkyl halide and our base is OH minus ion. So how the E2 and SN1 reaction occurs in the same starting material using base. So first is the SN2 reaction, in which the OH minus ion attack the carbon atom and bromine as the leaving group, that is eliminated from the starting material. At the same time OH minus ion form a bond with the carbon and the substitution reaction will occur. Whereas in E2 reaction, elimination occurs simultaneously. The abstraction of the proton from the carbon atom occurs. So the alkene is produced in the E2 elimination reaction. So generally we can conclude that if a nucleophile attack a carbon, then the substitution reaction will occur. Whereas if the nucleophile pick out the hydrogen, then E2 elimination reaction will occur. See, in this example, SN2 reaction prefers primary, secondary and tertiary. And in E2 reaction, E2 elimination reaction, the preferential order of the substrate is tertiary greater than secondary greater than primary. So the order is just reverse than that of SN2 in E2 elimination. So consider the primary alkyl halide and our base is O minus, CH3O minus. Then what will happen? If it is a primary, naturally a substitution reaction is favored, because according to this concept SN2 reaction favors the primary, so the substitution reaction will occur. Simultaneously there is a little minor product of the alkene is produced. So 90% possibility for the SN2 and only 10% for the E2 elimination. Next, if the starting material is a secondary alkyl halide, now same base is used. So the substitution undergo 25% substituted product and 75% eliminated product is obtained. Whereas in the case of tertiary alkyl halide, the 100% elimination product is occurred. That means elimination favor the tertiary substrate more than that of secondary than that of primary. Now we are considering other factors which affecting the competition between the substitution and elimination reaction. See, if we take a weak base means it may be a poor nucleophile. For example, water is a weak base, at the same time it is a poor nucleophile. Similarly, methanol. So in that case, in primary alkyl halide, there is no reaction will occur. Methyl also there is no reaction will occur. But in secondary and tertiary, maybe the possibility of SN1 or E1 will occur because both the reaction undergo through a carbocation as the intermediate. Now, if we take a weak base or a good nucleophile, for example, iodine I minus SMe minus Cn. In this case, for the methyl, SN2 substitution reaction will occur. Primary also SN2 reaction will occur. And for the secondary and tertiary, SC1 or SN1 or E1 or SN2. It may happen depending upon the condition. And if our base is very strong and good nucleophile like OMe minus NH2, in which methyl group undergo SN2, primary alkyl undergo SN2, then secondary will undergo SN2 or E2, and tertiary only undergo E2. Then if we take a strong base and poor nucleophile, so in methyl SN2 reaction will occur. In primary alkyl halide SN2 or E2 will occur, whereas in secondary and tertiary E2 will occur. So we can compare the result to the above slide. So consider in alkyl halide we will get 90% of the SN2 product. Okay, and the charged ion as a strong base. So in the third column, strong base for the primary SN2 is preferred, whereas in secondary we will get an eliminated product as the major. So here both of them are possible, whereas in tertiary, in the case of strong base, we will get only E2 elimination. See here in tertiary alkyl halide only E2 product is obtained. Now we are summarizing some of the point here. The factors which affecting the competition between the elimination and substitution reaction. These are the some of the other factors. First one is the temperature. We know the equation delta G is equal to delta H minus T delta S, and whereas S is the entropy. So entropy is more for the elimination reaction. So as the temperature increases, the elimination reaction is favored. So the second factor is the basicity of the nucleophile. So the nucleophile attack at the carbon atom leading to the substitution reaction that we discussed earlier. And if the nucleophile attack a hydrogen or a proton abstraction, it leading into the elimination reaction. And here the strong base are good at extracting proton. So in that case, if we are using the strong base, elimination are the result. Now the next factor is the bulkiness of the nucleophile. So the bulkier base induces elimination reaction because as the group is bulkier, it is very difficult to substitute in many of the substrate. That's why the elimination favor. And more basic the nucleophile, the more likely that undergo the elimination is going to occurs, because as the basic nature the nucleophile, the elimination reaction is more favored because it can easily pick out the hydrogen from the substrate. Now, sterically hindered base are good proton abstractor but poor nucleophile. So, it also favor the elimination reaction. And the fourth factor is the nature of the substrate. The elimination is favored in the increasing branching of the carbon chain, because we know that as the substitution increases in elimination reaction, the stability of the alkene also increases. That's why as the branching in the starting material increases, the elimination reaction, the possibility for the elimination reaction also increases. Then as the bulkiness of the nucleophile increases, also the elimination reaction favors. Now, the nature of the substrate. Elimination is favored with increase in branching of the carbon, and it enhances the stability of the resulting alkene. That's why the presence of stabilizing group such as phenyl, vinyl favor the elimination reaction because the conjugation in the product. The fifth factor is the nature of the solvent. A less polar solvent favor the elimination by E2 mechanism because the nucleophilicity of the attacking agent cannot be altered if you are using less polar solvent. That's why E2 elimination will occur. Then for an aprotic solvent allows the increase in basic strength. Okay, so because if we are using aprotic solvent, it does not make any influence of the basic character. That's why the basic strength of the aprotic solvents is also increases. Now consider one example. In this example, our base is KOH. We have already discussed the difference in structure of the substrate. Now we will discuss the difference in the bulkiness of a base. In the first case, we are using KOH as the base. In that case, the chlorine is replaced by the OH group. But in the second case, KOET tertiary butyl is the base in which the elimination will occur. So these are the difference between the bulkiness of the base. In the case of bulkier base, we will prefer the elimination than that of substitution. Thank you.